Bismillahirrahmanirrahim. Let's start the second part of the lecture on shearing force and bending moment diagrams. Right. So over uh, we were over here last time where we finished. So if we have a cantilever beam and a load of 100 pound is applied on that, and we take the section at particular point, so there will be a force that will be equal and opposite to the applied load. That will be called shearing force V over here, like this one. You see the shearing force over here, right? And this is equal and opposite to the load P which is being applied, right? And what we discussed in case of the transverse loading, V is always V for this particular case, V is constant. We take any section at any point, V will be equal to the load applied on that, right? But since M is the function of A is the distance from the point of load to any other point. In this particular case, it was over here, right? So it is a function of A. So A will be keep on changing as we keep on increasing the A. So the moment will be keep on increasing, right? So in this particular case, V will be constant. In this particular case, V will be constant, but M will be keep on changing. But B can also be changed if we take another loading condition like uh, this one, like this one where we have this load P1, this load P2, and then you have some load over here as well, right? So in this particular case, if we take the section over here and then take the section over here and then take the section over here, in all these cases V will also be changing and moment will also be changing again. So it all depends on what sort of loadings you are having on your beam, uh, and then you can calculate accordingly what is V there and what is moment there. So in this particular case, if I talk about, then the shearing force and bending moment diagram will be telling us uh, uh, the V max and the M max value, right? So where at which particular point shearing force is maximum, and at what particular point moment is maximum. And obviously when moment is maximum, and we know that sigma is mc over I, sigma is mc over I. So when m is maximum, so sigma will be maximum, means normal stress will be maximum over there. So the main purpose of whole of this shearing force and bending moment diagram is that it will tell us where is the on a whole beam, where the V is maximum and where the M is maximum, and where we have to pay, and these are the points, and definitely that give us the magnitude of the V as well as moments, right? So in this particular case, if we have a cantilever beam and a load is applied in this direction, say 100 pound, ठीक है, then it will be giving, uh, it will be in this shape, right? After this, and we know that since this is the function, this moment is function of, this moment is this moment is function of A. When A will be maximum, so it will be, moment will be maximum. So this is the point, this is the particular point where this moment will be maximum, and that will be again, it will be this, at this point with the sport, or the point from where this cantilever beam is fixed, right? So this will be this will be the point where you will have maximum moment, resultingly maximum stresses. So this part may be the more vulnerable part that get into the failure when a 100 pound fit 100 pound load is applied on the tip of that particular cantilever beam, right? So next part is basically what we discussed was that we, sorry. So next part that we discussed was that now we are coming on the sign conventions, right? There are two things. One is the static part. This is the static part, right? This is the static part. Static part, we have x-axis, we have y-axis, and then we have z-axis. These x, y, z-axis are basically the positive axis, right? Positive x, this is positive x, this is positive y, and this is positive y. And a particular force in this direction is assumed to be the positive x force, positive y force, and this is basically the positive moment, that is basically the counter clockwise, right? This is counterclockwise attraction. So the moment is positive counterclockwise, and rest of the forces in positive x and positive y axis. So equilibrium condition is sum of all the forces in x direction is equal to 0, sum of all the forces in the y axis is equal to 0, and sum of all the moments should be equals to 0, right? So now we come to a point that what is this force. If I draw this force, supposingly if I draw this force, is it a positive force or it is a negative force? Obviously this is a positive force, right? Because it is in the positive x direction. But is it a compressive force or a tensile force? It depends. No categorical answer, I can't say anything. But force is positive. Statically, it is a positive force. But as far as the nature of the impact, it is a compressive or tensile, it doesn't show this. Then if I put over here a load and then equivalent opposite force, that is negative, statically applied on it. So now you can see it is a compressive force, right? And compressive force is always negative one. Likewise, tensile force is always positive one, right? So statically, if a force is positive, it never means that they will be a tensile force or the compressive force. You'll have to see that equivalent opposite force is applied on the other side of that, and then you will decide it is a compressive force or a tensile force on it, right? Good. We move forward a bit. Right. So now if this is a piece, right? This is a beam of this section, and we applied a load on it. And not load, we apply a moment on it in this direction, right? You can see this direction. This is direction of the movement, right? So if you apply the moment of this direction, so it will be going to into this shape. It will be going into this particular. So let me draw it first again. Right? So what happened? That this is the positive force, positive bending. This is what we already know from the chapter 4. That this is the positive because it is in the positive y direction. This is x, this is y. Since it is about the positive y axis, so it is a positive force. So positive bending. So inner surface is basically under compression and outer surface is basically on the tensile one. Right? So bending, if you look at the moment, so moment one is statically positive, one is statically negative one, right? This is positive one because this is counterclockwise, and this is negative movement on that. Just like the forces we apply over here in this particular case, that one was statically positive and the was statically negative, and it is causing compression, right? Likewise, positive movement and negative movement is causing the bending, positive bending, right? Inner surface is under compression and uh, outer surface is basically under the tensile. Likewise, if you come to this point, at this point you can see that this is positive and this is negative statically. And this positive and negative movement is causing negative bending. Negative bending, right? And we know what is the characteristic of negative bending. The top surface is always in the tensile, and the bottom surface is always, the inner surface is always in the compression one, right? So this is by the end of the day, you can say this is a smiley face, and this is a sad face or the grounding face. So whenever you have a smiley face, obviously you can say that is a positive bending, and whenever you have a sad or growling face, a frowning face, then you can say that that is a negative bending, right? So but at this particular point, what about the shear force now? Obviously there would be some shear force. This is what we have already seen. If you look at this section, particular this section, it will be like this one, right? This will be a higher side and this will be a lower side. When it will be a higher side and the lower side, so you will be into this one, right? So if you look at this, so you will be into this phase, right? So this is basically upside, this is downside, and this is basically going down, this is going basically up. And that effect of this shearing force will be this one, clockwise, right? So if left side is up and down, right side is down, and the effect is basically they are circular, they are into the clockwise direction, they are in the clockwise direction, so it will be a positive one. And if you go over here, it will be exactly opposite to one, right? So now this will be the part. This part will be upper one and this part will be lower one, right? So now the arrow will be, effect of the arrow will be counterclockwise, right? And whenever the counterclockwise is there, so it will be negative one, right? So this is how you can see the shearing force is, if the shearing force is circular, is generating a counterclockwise or clockwise direction, so you can assign positive or the negative shearing force accordingly, right? So now if you go for this one, so now if we have some sort of, I mean, if we have this sort of shearing force bending moment diagram in which you have initially a positive one, then negative one, and then this sort of stuff is there for the moment one. So this is the positive shear, right? This is a positive shear because it is the positive direction, and this is the negative shear one, and this is the negative shear one. So when I see this, so I can see that this part is going to be this part, right? Whenever you have this sort of condition, you will draw it positive one, and whenever you have this sort of situation, you will go for the negative one, negative one. And as far as movement is concerned, we know that movement always positive one is a smiley face, and the negative is always the sad face. So whenever you have this sort of situation, so you can say that this positive face is always creating a smiley face, right? And this part is always a in this part. I mean, the beam in this particular, the beam in this particular condition, in this particular condition will be smiley face, and in this particular part will be a smiley face, and in this particular part uh, it will be a sad face, right? Now, for example, you have this sort of example. If we take this example, right? So what is happening over here? You have simply supported beam, right? And you applied a load over here, P. So what will happen? It will go into this one, right? So it will be a smiley face, means this particular condition when we'll draw the shearing force and bending moment diagrams. So as far as moment is concerned, this will be always be a this will always be on the positive side of that one. Means it will be like but it depends upon the, so it will be like this one, right, or like this one depending upon the positive side, right. So it will be over here, it will be gradually increasing as the A increasing, and this is the positive side of the bending, right. And if this load is being applied from the downward, from upward condition, so it may come on the negative side of this one. In this particular case, load is being if load is being applied into this direction, so this would be like this one, because then it will be a it will go into this shape. That is a smiley, that is a sad face. A sad face I know is a negative moment, so it will be in the negative side of the one, right. Likewise, if we have a cantilever beam like this one and we applied a load at P, so we can see that it will come into this particular shape, right? This particular shape. And then we know that this is basically a sad phase, so it will be going into the negative direction. And we always know whenever there is negative bending, so top surface will be in the tensile and the inner surface will be in the compression one, right. And what about the Z? You see that everything in this section will be into this one, because it is continuously coming downward, right. So it will be this way. So this is up, this is down. Net is basically like this one, counterclockwise, and we know that counterclockwise is always a counterclockwise is always a negative uh, shear force, right. So this is how you can have an idea what is happening and what is positive, and these are the standard convention. Now we have this example, for example, that beam length is 6 feet, 100 pound is the load applied at the tip, and then you have the A distance over here. A distance is this one, right. Obviously we know that whenever it will go into this one, this particular load will cause this sort of stuff. So we know everything is negative there. Negative moment, negative negative moment, and negative V, because this is because of this one, right. So everything is in the negative direction. This is negative 100 because V in this particular case, V will be same across the beam. So it will be constant, right? So it will be constant 100 because it is negative 1. So it will be in the negative side. Whereas moment again is a function of 100, the function of A. So moment will be 100 into A, and maximum will be 600, and that 600 will be over here into this one, and this will be a continuous slope, right. Another way how by which we can have that, if we have some sort of uh, like this is a face, smiley face means positive one, so we can look into the slope as well. If the slope is negative, so shearing force is positive, and if slope is positive, the shearing force is negative. This is another idea. That's how we can go for the estimation. So these are basically the sign convention, and these sign conventions are different from the static conventions which we generally use to go for it, right. So here I'll stop sharing this one. Now I'll share with you the regular chapter, right, and then I'll finish the theoretical part of this chapter, right? So this is chapter 5. So objective is analysis and redesign of the beam. These are very important part of the design, because by using this shearing force and bending moment, you know where the maximum moments are occurring, where the maximum shearing force is occurring. So both of this are basically the both of this cause the will tell you where what are the points which are more vulnerable for the failures, right? So these beams are very important part of the structure, obviously. And transverse loading, we have already know that transverse loading is the loading that is applied perpendicular to the longitudinal axis of the beam, and further classified as the concentrated load as well as the distributed loads, like this one. These are basically the concentrated one. Sorry, these are the concentrated loads. These are the concentrated loads, and this is the basically distributed load, right? And then you have the applied load results in the internal forces. These are all the internal forces which are which are causing the stresses, and loads are applied externally. Whenever there is external load is applied, body go into the reaction, and reaction all loads, externally applied loads, are used to call actions, and the body generates reactions that is that is in the form of stresses as well as the strains and the movements, rest of the stuff, right? So shearing force and bending movement are diagrams are particularly used for the shear force as well as the bending couples. This is what we have already know, that sigma x is m minus m by over I from chapter 5, and maximum is mc over I, or m over section modulus. This is what we have already discussed in detail into the chapter chapter 4, right? So whenever you have, so you can see that this is the force, right? And this is basically the and then you have the moments as well into this particular case, right? So these are basically different type of the beams. You can see that these are statically determinate beams, statically indeterminate beams. We are primarily will be dealing either with this type of the beams or maximum with this type of the beams. The rest we will not discuss in detail of them. So how we will go for the maximum one? Obviously, whenever you have the loads, so you take the sections of those loads, and then on that particular sections you draw the direction of the shearing forces and the moments, and these are all the reactions, right? And on the basis of reactions you see either that is a positive bending or positive movements, or the negative movements, likewise positive shear stresses and the negative shear stresses, right? So these are the sections, these are the basically the conventions. These are the positive shear and positive bending moments conventions, right? This is what we have already detailed discussing today. So here I'll stop my this lecture. From next I'll go for these problems, sample problems one by one, and then definitely we'll go ahead accordingly to cover this chapter next time, inshallah. Thank you very much. Have a nice weekend, and Allah Taala khair wa afiyat rakhe. ठीक है, thank you.